Having this already on my
The aggressiveness of that cold front. We could have just thunder showers, we could have showers, we could have tornadoes, we could have multi-cell activity. The degree of activity is dependent upon a number of variables which we'll look at later. But there are all kinds of possibilities, but every one of them would be intense precipitation. Short zone, but very intense. Okay, as this continues to move, we'll siphon more and more and more of that cold air down. So this is just moving across this landscape in that manner. Now, if this is really an active cold front, what we'll find is literally winds being shot out well in front of the cold front, and this is called the squall line, and it's turbulent weather. Air is being pushed up, cooled, and then shoved it back down toward the Earth's surface. Squall line precipitation can be very intense as well. Wind activities here are great. Not a lot of rain, but intense in the form of winds. Then as this passes, we'll have cumulus clouds back here, puffy altocumulus, indicating pleasant weather. Okay, let's take the other one. There's our warm front. Again, the isobars on it. Would be something like such. So again, air is moving into that low counterclockwise. So behind the front, the winds are coming from the south-southeast. Ahead of the front, the winds are coming primarily from the northeast one. Now, what we should notice with the front is a massive cloud buildup and rain that literally goes for tens of miles, maybe even 100 miles of rainfall. So this would be the area of precipitation. And it gets sucked into the backside. As it moves in, it moves around to the backside of that low. And we'll end up with rainfall all the way through here. Now, if we take this and do the same thing with the front, this is a warm air, the empty air mass. This is cool air. The warm air is going to rise, and as it rises above this, end up with layer-like clouds, and those are which ones again? Stratus. And precipitation literally may be over a great geographic area. Not intense, but long-lasting. I mean, we had two days of it. And that implies that this warm air mass is moving across this thing very, very slowly. And what we had this weekend was a slow air mass pushing across the landscape, and in doing so, the warm tropical air is cooling off and precipitating in this region. Now, we anticipate thunder, lightning with this? No. This you should just nice and calm. Actually, very low wind activity with this. And you should not end up with any violent activity such as thunder, lightning, and so on. Let's do one more area. What do we have up in this area? What kind of a front? Okay, that's an occluded front. And if we were to take a cross section through here, CC prime, what we would see something like this. Cold air on the ground on this area, cool air here. Where's the warm air?
Up.
Up. The warm air has been pushed up. And occasionally, not frequently, but occasionally, we'll have stratus clouds in through this area, but there will be thunder and lightning associated with those stratus type of cloud. What you see are stratus on the surface. But what's happening above this is this warm air is being displaced, and that's where the turbulent activity is taking place. That's where the lightning and thunder is occurring. But you look up and you say, hey, stratus clouds, we shouldn't have thunder and lightning. It's happening above the occlusion where the warm air has been pushed upward, and it's a cumulus cloud. Again, the center of the low is right here in the center of this cyclone, mid-latitude cyclone. Okay. The sequence of events from this point, starting point, to the ending point. Location A will experience the following types of phenomena. Initially, the winds are from the south-southeast, maybe southwest. Coming from the south, so temperatures are going up, humidity is going up. The front's getting closer, so what's happening to pressure? It drops. As that front gets closer, pressure drops. Wind speeds may increase because of the pressure drop. When the front hits this area, rainfall will occur, cumulus clouds will form, rainfall will occur. If it's very active, maybe thunder, lightning, we don't know. Cold front passes. After cold front passes, the air clears, the wind comes out of northwest, and pressure goes back up. Again, remember the lowest pressure is right at the front, so as it passes, the pressure is going to go up. This is what your local weathermen use to forecast the weather. They can now predict where these cells are going to go. I mean, this is a recent phenomenon. Within your lifetime, you can literally have 3- and 5-day forecasts that are rather accurate. Up until that time, if you had a 24-hour forecast, you were fortunate. So again, computer models have aided in basically giving us some insight into what's happening with daily weather. Questions? If I put one of these in our quiz, you can tell me what's happening? No? Okay. Questions then? Yes? What? Oh, starting point and end point. That was, if we started at this point with the cold front and moved it to that point, we had just a starting point and end point. So at the starting point, you'd have winds from the southwest. At the end point, they'd be from the northwest. So all that is okay, this is where we started, this is where we ended up.
And if you did that on a test, that would be our correct answer?
That would be what?
The answer?
What, SP and EP?
No, the wind starting from the northwest, ending at...
No, they started from